What's up, guys? This is John Chapone. We're talking about indirect proof. It's another way of assuming a premise. So we already covered one way of assuming a premise, which was conditional proof. If you have a conditional statement, an if-then statement, a horseshoe in the conclusion, you can assume the antecedent, and now you just have to look for the right-hand side of that horseshoe. And once you get it, you close off the box, you assert if P then Q, and you're done. In this one, you're assuming the opposite of what you want. We actually do this in life a lot. So, for example, as a student, I was a painter, and a friend of mine wanted me to help him paint his kitchen. So we went to the store. I showed him what paint to get. What's the best paint. And he didn't want to buy the primer, and I tried to explain to him, no, you got to have primer because we have to do work on those cabinets, and we need to prepare that surface to be painted so that everything's the same. And he said, no, primer's for stupid people who don't know any better. It's just a marketing scam. You don't need primer. All right. He didn't want to buy the primer, so I was going to argue with him. Maybe he didn't have the money, but I knew in the end he wasn't going to be happy, and he was going to have to buy more paint and primer. It was going to end up costing him more. So basically I said to him, let's assume that I'm wrong, and let's not buy primer. Let's see what happens. What happens is wherever you did work, it will be flat, and where you didn't do work, it will be glossy. So you have these different textures of gloss and semi-gloss and flat all over your cabinets. It was a horrendous nightmare. He could see something like a contradiction, right? It's like a contradiction. It's not what you want. So he could see, okay, this is not what I want. We have to go buy primer, and we have to do it all over again. At that point, I said, but you're on your own. I'm not going to help you from here on. You can, it's not a big deal. You can paint. You can paint this all over again on your own. So we do that. We assume, like I said to you earlier when we're doing indirect proof or conditional proof rather, that when you're selecting what you want to do for a living, you'd ask yourself, how much do you want to make? Let's say you want to make $75,000 a year, because you read somewhere that people that make $75,000 a year are just as happy as people that make $75 million a year. I don't know if that's true. It wouldn't be true for me, but supposedly that's true for a lot of people. And that's what you want. So assume you already have a degree in nursing. Will you make $75,000 a year? Then you do your research and you find out, well, if I already had a degree in nursing, I would not be able to get a job making $75,000 a year, or I would be able to get a job making $75,000 a year. It's the type of thing you should be doing, but that's conditional proof. Indirect proof is similar to, like in the Cosby Show, where his son did not want to go to college and get a degree. And so he said, okay, let's assume that you don't have a degree. And they played this whole thing out, and it was a disaster. He didn't like the consequences of not having a degree, so he went to college and he got a degree. That's indirect proof, okay? It is a rule of inference. If we assume a premise and it turns out we end up with a contradiction, we can assert that the opposite of what we assumed is true. In other words, that the premise that we assumed must be false, okay? Here's what the rule looks like. You assume the opposite of the conclusion, because you're going to get the opposite of that when you're done. And then once you assume the opposite of the conclusion, you use the rules of logic to look for a contradiction. When you see a contradiction, let's say you have Q here and not Q here, you've got to put it together with conjunction. So this first line is always the opposite of whatever you want. This last line within the box is always a conjunction, which is a contradiction. So most likely, almost always, you're going to have to use conjunction at the very end to put together this contradiction that you see up above, okay? And then underneath the box, it's always the opposite of what you assume. And then you say from line, 3 to 7, indirect proof, okay? Or however many lines. So let's look at this one here. And we're going to use, there is a way of doing this without doing indirect proof, but we're not, I'm trying to teach you indirect proof right now. So you're going to assume the opposite of the conclusion, which is P. So I guess this is confusing because you might think that I assumed the antecedent here. And then when I get to P, then I'm going to close this box and say, if not P, then P. I could have done that. I could have done conditional proof. That's what I would have gotten if I was assuming the antecedent. I'm going to get if not P, then P. But I've already got that. So why would I do that? I guess if I needed this down on line 5 for whatever bizarre reason, I could do that to move it down. I showed you in my lectures how to move something down. It's pretty rare. You're not going to have to ever do that in any of my arguments that I'm giving you on the final. All right, so we ended up with, we assumed not P, then through modus ponens, we dropped the P down. If not P, then P, not P, therefore P. Then you can't close this off and say P from 2, 3, IP, indirect proof. You have to use conjunction, and you have to have P and not P. So you're going to have P comes from 3, and the not P comes from 2, so that should really be 3, 2 conjunction, but that's a nitpicking type of thing. You can put that in numerical order if you want. And if I wanted, I could have had this as not P and P. It doesn't matter what order you have that in, okay? The last thing is the opposite of what you assumed, because you know that if you assume that the conclusion is false, you end up with a contradiction. So it's got to be a valid argument. We're assuming that P then has to be true. And you can pause it here, use the short method to determine if this is a valid argument. This is an easy one, actually. And then come back. All right, in every one of my video lectures, I tell you to start with a simple proposition, and students that are in my class often don't do that, and they get into trouble. And it's either, believe it or not, it's either because they don't remember me saying that. Even if I didn't say that, it's just so obvious. Start in the easiest place possible, which is a simple proposition. You shouldn't have to be told that. It's the easiest place to start. That should be obvious, so start there. But it's not to a lot of students. And some students haven't been doing the work. They're not listening. And some viewers they don't remember, they're not listening. They don't know what a simple proposition is. At this point, that's a huge problem because that's a day one. We talked about that right in the beginning of the class. So you would start with the conclusion. That's the only simple proposition here. Premise number 1, these are both propositions, right? This is a proposition. It's a statement that's true or false. It's compound. Not P is compound, not P, then P is compound, okay? P is simple. It's a conclusion. It's also a proposition. So the premises and conclusions are both propositions. All right. We are starting with P by making it false, but then you have to be consistent. You have to make every P false. The tilde flips the truth value of this P. So now you're looking here and here. You've got true, false, and I hope you know by now that that means this whole thing is false. So you can check this off, but you're going to have an X over here. That proves that indirect proof is a valid rule and a valid inference. And we're going to be using these rules up above, all of these rules, plus conjunction. So the only other rule you should need is conjunction. All right, let's do the first one, so you know how to do this. We would assume the opposite of the conclusion. We're going to assume the opposite of every one of these conclusions, okay? So you just put a tilde in front of it. Unless the conclusion was not S, then you would have assumed S. You don't have to have tilde S, and then, you know, use double negation to get down to S. You don't need to do that. Well, at least not in my class, you don't. So then just start doing logic. I can simplify the P here. Look for another P, is right there. So now you have the same antecedent. Look for the rules under the horseshoe. When you have the same antecedent, you can bring down the consequent. So notice I'm bringing the consequent down without the brackets. If you brought the brackets down, then a logician would just think you don't really know what you're doing. I mean, you're not making a mistake, but you don't need brackets because there's no reason in line 5 to identify the main operator. It's clear that it's the horseshoe. And that's from 2 and 4, and the rule is modus ponens. So now if you look at 5 and 3, we have the same antecedent again in a horseshoe. So we're going to bring the S down, and we're going to use modus ponens on 5 and 3. Now, you may see the contradiction of not S, and here's an S. You cannot close this off and then go to line and then go to line 8. Okay, you can't do that. You have to put it together using a conjunction. This last line in the box is always going to be a conjunction, unless what you had in line 2 was not S and S, okay? Then when you bring this down, you're going to end up with not S and S. Well, that is a contradiction. It's a stupid argument, but you'd be done. Then you would just close it off, and you would say, okay, so that S must be true. All right, pause here and do number 2, then unpause, and I'll show you how I did it. All right, we're going to start by assuming the opposite of the conclusion. Just put a tilde in front of the P. Look for another, and I draw a line out to remind me I've got to close off this box, but you don't have to do that. But I recommend it because sometimes you will close off the box in the wrong location. You forget where the premise was that you assumed. It's a careless mistake, so it's a pretty good idea to draw the line out to remind you where the assumed premise is. And then over here you're going to write assumed premise, AP. Look for another P. There it is. Okay, this is a horseshoe statement, so you're going to look at your rules of a horseshoe statement where you have the opposite of the left side. Here's the horseshoe statement. Here we have the opposite of the left side, which tells me I can bring the opposite, the opposite of the right side. Wow. Tells me I can bring down the opposite of the left side, right? All right. Now look for another U. So when you look up above, you realize there's no other U, so I'm not going to be able to use that for anything. It was a waste of my time. Then that means that the premise number 1 is actually a red herring. It's a red herring, okay? So I'm going to either break this apart. I'm going to do this the long way in elegant proof, so it's easier to see how to do indirect proof this way. Again, I don't need the brackets. No, I'm not going to need the X. I'm going to need, what I'm after is this contradiction right there. I'm simplifying the not T from line 4. Now I'm simplifying the T from line 2. And now I'm not doing to do this. You don't do that, okay? Do not do that. You do this. You either say not T and T, or you say T and not T. The T came from line 6. The not T came from line 5. And we use conjunction to put these two together. There's a contradiction. Now we are going to close up the box just like we used to do when we did conditional proof and we assumed a premise, okay? What's on this last line is always a conjunction and it's always a contradiction. What's in this first line is always the opposite of the conclusion or whatever it is you want. What's on this line, the last line underneath the proof, right underneath this line here, what goes underneath that is always the opposite of what you assume. So here and I don't mean not P, you can just put P down here. And we use line 3, and we went all the way through to line 7, and we use the rule of indirect proof, and we're done. So why does this make your life so much easier if you can't figure out how to get started? Well, you can do that, you know. Let's look at a way of doing this without using indirect proof. Oh, it's unfortunate. Okay, hold on. All right. Now I'm going to show you what I said earlier, that would have been a faster way of doing it after you did indirect proof, and that would have been to move this bracket over. Let me just let's start over here. I'm assuming I'm doing indirect proof, the opposite of the conclusion. I'm writing AP for assumed premise. I'm drawing my line out to remind me that I have to close that box off, and I have to close it from here. Okay, I don't even think it's going to be that long. Now I'm going to move this bracket over. What rule do you think I'm using? Look at your rule sheet. I'll pull up the rule sheet for you. Here, with an AND statement, a string of AND statements, we can move the parentheses over. Or with a string of OR statements, we can move the parentheses over. And that's association. Commutation is when you flip things around, okay, in an AND statement or an OR statement or a triple bar statement, okay? So we're talking about, I could have used association. And now I'm just, whoa, wait, what the hell am I doing here? Hold on. Talking and doing logic like chewing gum and talking for me. It's just not favorite. All right. Now I'm simplifying, and the reason I wanted to show you this is because on line 4 I have simplification, and this is a very rare instance where I would not need to do conjunction because I've already got a conjunction that is a contradiction. And on line, so the very last line is always a conjunction, which is a contradiction. So you almost always have to have a conjunction here, because you almost always have to put the, but in this case we don't need to do that because we already have it together as a conjunction. All right, so we used we have to put the opposite of what we assumed here, and we use line 3-5, 3 to 5. Indirect proof. And this is the most elegant way of doing that. And it's important that I show you this way of doing it because it's a rare case where you don't need to use conjunction to end up with the last line within the box. All right, but I said that Microsoft's got to do something about giving us the ability to go back further, and computers are so remarkable at this point. There's no point of not doing that. All right, how we already said that line 1's a waste of space. So how would we do this? I'm going to proceed by using association again. Hey, little boy. Then I'm going to go same steps as before, almost. If you wanted to, you could have just simplified this whole thing out and not used association. And maybe that would have been a better way of doing it in retrospect. Now I'm going to simplify the not T on 4. And we could have done this whole thing with simplification so far. And then I'm going to bring down the T on 4. Now this is actually a very hard proof to do if you don't have indirect proof and you don't know this move. Then I'm going to say if T is true, or P is true. And that's addition on 6. Now, what do you think you do? How did I get the P? From 7 and 5, and the rule is disjunctive syllogism, and that is the conclusion, okay? So from a contradiction, if you have a contradiction in your argument, you can create the conclusion using using addition and disjunctive syllogism. Every argument that has a contradiction in it is valid. Unfortunately, I wish that wasn't the case. It just is, okay? Oh, I might as well get rid of this whole thing, right? All right. Well, we could go back to the slideshow and do number 3 now. Or you need to pause it and do number 3. and then we'll come back. Unfortunately, I already showed you number 3, so you're pausing it with number 3 on there, right? Let's just go through it. Assume the opposite of the conclusion. And then you put AP for assumed premise. Draw your line out. You have to simplify 1 and then simplify 1 again. You can't just say Z from line 1 modus ponens. You have to simplify. You have to break it apart in order to use modus ponens. I'm looking for another Z. It's right there. X, then not Z. Z. Okay. So I could assume not X, but I didn't do that. I could use modus tollens. But I ended up with not Z because I have an X here. If X, then not Z. X, therefore not Z. So my contradiction is with Z and not Z. I'm using conjunction to put those together, closing it off. Then at the very last line, I'm saying it turns out that what we assumed is true. We assumed it's false, but it's true. So the opposite of what we assumed goes here. Line 3 to 8, indirect proof. Now, I have here that there's another way of doing it. Here we ended up with a contradiction between the two Z's, Z and not Z. Well, we could have had a contradiction. There's actually another way. We could have had a contradiction between the two X's. Am I right about that? Yeah, sure. I would have had X and not X, yeah. Alright, I simplified 1 out on line 3 and 4. Then I use this if X, then not Z. Oh, wow. This is such a complicated argument. It's valid in so many different ways. Wow. Wow. Let's because wow. Hold on. That's one way of doing it, okay? I didn't realize how fascinating this argument was that I came up with. Okay, there's one way of doing it. Now let's go back and come up with the, I don't know, I really should have put a line between this so we know what we're doing. It doesn't get confusing, okay? Here's the other way that I did it. We'll go through all, I'll show you all 3 different ways. Okay, in this second way, I ended up with simplifying the X, and now I have this not Z here. X then not Z, X therefore not Z, X then Z, X therefore Z, and that's a contradiction here, and I'm not using indirect proof, so I'm saying W or Z, not Z, W. I showed you that trick earlier, and this is actually more elegant, but that's using disjunctive syllogism, you know. So let me show you another way of doing this. I don't know why my computer's doing this lately. It's just, for whatever reason, it doesn't on the first time pick up on my copy command. Alright. So maybe some of you noticed this. I did not notice it. There's so many ways of doing this. That's from one, simplification. So now, believe it or not, I could say x, then z, no, that's not, what am I talking about? That's not a contradiction. I was thinking that this is a contradiction. That's not a contradiction. I don't know why I was thinking that. In order for it to be a contradiction, I would have to have something like, if there was a tilde in front of here, that would be a contradiction. Sorry about that. Oh, so there's another way though, which I didn't cover. I alluded to it, but I didn't show you how to do it. So we're going to assume a premise. And now you see over here, before when we assumed a premise, we ended up with this contradiction. Alright, so there's another contradiction in here. My cat locked herself behind. I don't know if you can hear her, but she's upset because she's locked in the room. There's a litter box in there, and food and water, but she shut the door. Okay, this is from 5 and 4. Motor exponents, and now I'm going to say if x then not z, z therefore not x. So we've got this is from 2 and 6 modus tollens. Now I give a different contradiction, and you could put the not x first. It does not matter. And that's from 7, 4, conjunction, and I usually would say x and not x. I don't know why, but I don't see why it matters. Which is more elegant? Neither, because we're not done yet. So we got to close this off. And then what goes underneath this? Remember what I said, you always get a conjunction that's a contradiction, and almost always you're using the rule of conjunction from 2 different lines. But see how it's the same number of lines, right? And so this is, we assumed not W, so W must have been true. We went from line 3 all the way to 8, and this is another example of indirect proof. So we have 2 examples of indirect proof, and we have an example of doing this without using indirect proof. All right, pause the video. What you're going to do is you're going to do number 4. I'm not going to have a proof in my PowerPoint presentations for number 4. So we're going to be doing that next. Alright, so pause the video and do this one. Okay, just became concerned here because all evidence that I was recording disappeared off of my screen for whatever reason. But it looks like I might still be recording. Alright, here we have an S, so we're going to assume that S is false. And then we're going to put assumed premise, okay? AP. Okay, so I hope you've paused this and tried this one on your own. What we're going to do is we're going to simplify number one. Okay. Then look for another P. It's in line 3. And we're going to do modus ponens because here's you have a horseshoe. You got the same antecedent, so you can bring down the consequent. And you don't need the brackets though, because the brackets are there to identify the main operator. You don't need to do that now. Alright, we might need the U, and we might need the not T, because I see a U and I see a T. So I'm simplifying the U. Now I'm going to simplify the not T. If you think you could have just simplified T over here, then you're kind of in big trouble. You know, you can't simplify a horseshoe. So, remember we're looking for a contradiction. Where's there another T? It's there. So we have the opposite of this, so we can bring down the opposite of the antecedent. And this is from what we had, how to get, not T came from 6 simplification. So we ended up with a not U from 2 and 8. And that's modus tollens. You can't do this. You cannot do this. You're not done. We have to put the contradiction together. And there's a U in 7, or you could have said U and not U. I don't care. The not U came from 9, and the U came from 7, and this is conjunction. And we have to close the box off, because if you were to continue to do work down in this direction, you can't go back in here and grab stuff that's hypothetical. Okay, we know that assuming the conclusion is false results in a contradiction, so the conclusion must be true. This last line is always the opposite of what you assumed over here. And this line is always a contradiction that you put together as a conjunction, or you just ended up with that contradiction because it already was in the proof as a conjunction. That's how you would do 4. Let's go back to our PowerPoint. But at this point, I think a lot of you would know what's going on. Let's try these. pause and come back. All right, let's look at how we did number 1. We started by assuming that the conclusion is false. It's always what you want to do, put a tilde in front of the conclusion, or if there is a tilde in front of the conclusion, just take it away, okay? And I'm talking about the whole conclusion. The conclusion might not be a simple proposition. It could be a compound proposition, in which case you would put brackets around it, and then you would put a tilde in front of the entire thing that you bracketed off. That's the contradiction, okay? You have to deny the whole thing. So that leads to some interesting situations, because if you have an or statement at the conclusion and you bracket it and you put a tilde in front of it, now you can do De Morgan's rule on that, okay? All right, let's see how we did this. I assumed not P is true. And you, by the way, you may not need this anywhere. So at this point, I can't use it right now. I can't do anything with this. I can't bring the A down. I have to break this apart first. So I notice there's a contradiction here. I can bring the S down. It's not a contradiction, but A and not A. I can do disjunctive syllogism and bring the S down. Then I'm looking for another S. It's here. So if you look at your rules, you've got the left side of a horseshoe, and you do have that. You've got the antecedent. So bring down the consequent and leave the brackets off. Now we can use this not P and bring the A down. That's modus ponens. And I see the contradiction here, not A and A. Use conjunction to put that together. Bracket this off. And then what goes here is the opposite of what you assumed. It's from line 4 to 8. And the rule that we used was indirect proof. Here's the other way of doing it. I didn't assume a premise. In my opinion, this is a lot harder for most people to see. But you know, in my lecture classes, students do see stuff like this. It's really remarkable how good students get at logic, and they're able to do brain twisters towards the end of the class. So here. I have from 2 and 1 use disjunctive syllogism to get the S by itself. Then I use modus ponens. If S is true, then that is true. S is true. Therefore, the consequent is true. Now from line 1 and 5, because this is A and that's not A, so I can, if you wanted to just bring the P down and skip the not P, technically, you're ending up with 2 tildes here, and there's a reason why we have a rule of double negation. It's for this reason right here, actually. So a lot of logicians probably would not be okay with you skipping the double negation move, but I would be. So that is actually 7 lines, and this was 9 lines. All right, pause this and try to do that brain twister. It's not that hard. You're going to assume the not D is true. And then, well, I'm not going to tell you. I'll come back and I'll show you. Okay. Ready? I assumed that D is false, the opposite of the conclusion. And then I wrote assume premise. Now I have to, what I did was, and this is hard to see, I used addition to create the opposite. This is really a brilliant argument, actually. It's really hard to see. I used addition to create the opposite of the consequent of a conditional statement. So I could bring down the opposite of the antecedent, which is not P. And then I look for another P, and it's in line 2. Disjunctive syllogism gives me an S. Look for another S. Modus ponens gives me a P. And at this point, you need a contradiction. Here's a not P, P. You got to put those together using conjunction. Close the box off. And line D. On line 10, you have D, which is the opposite of what you assumed. You always have the opposite of what you assume. From 4 through 10, indirect proof. So that's a really wicked move. You can, at times, create what you need to get an antecedent, or create what you need, use addition to create what you need to get an antecedent, or use addition to create what you need to get the opposite of the consequent. Using addition to get the antecedent is easier to see. Let me show you what I'm talking about. Make up something here. My mouse is catching. This is a good example, actually, because this is something I see people struggling with all the time. I don't know why it is, but it happens all the time. All right. So this is supposed to be a cube. Okay. I need to get a better mouse or some pencil, or better way of a tablet, which I had. I've never used it. So I need to create this antecedent, and all I have is a cube. You can do addition like this. This is from 2, addition. Now you have a match, and you can do modus ponens and bring down the X. I'm going to get rid of this, so if you want to take notes, pause. All right. It's a great example because for whatever reason, students think you have to do this. I don't know where they're learning this from. That you have to always add to the right. That is not the rule. You don't have to always add to the right. You could. You're not, violating any rules, but this is incredibly inelegant, and it just looks like it doesn't matter how it looks. It's just not fully understanding what's going on in logic. So now you don't have a match. If you think you have a match, that's a problem. You don't have a match. You got to flip this around. So it's just, you can add to either side, so just do that, So this is 3 commutation. Now you've got a match. That's all I wanted to show you. Put that. And let's look at this, another way of doing 3. I assumed, that is 3. So in this other way of doing it, I realized if I just had a P by itself, I could bring this down and do De Morgan's rule. Yeah. I don't have a P by itself, so how am I going to get a P by itself? Well, this is a brilliant proof because it shows that you could assume not P, and then if you end up with a contradiction, and we do, you can assert that P is true. So you can use indirect proof to create something that you need to do work in the premises. It doesn't always have to be the conclusion. That's what I'm doing here, all right? So I look for another P, here it is. So I can bring the S down from disjunctive syllogism. I look for another S, here it is. So I can bring the P down by modus ponens. Now I see a contradiction, P and not P. I'm using conjunction to put those together. So P must have been true. There you go. Now I have something to work with. This is why this is a brilliant and very useful rule. Now I'm bringing down the entire right side of the horseshoe, the antecedent. That's through modus ponens of 1 and line 8. Then I'm doing De Morgan's rule on line 9. Then that gives me a double tilde here, unfortunately. Then I'm simplifying the right conjunct and doing double negation, and that's the conclusion. I'm done. Okay, pause and try your hand at these. All right, we're just going to do number 5 now. This is a really long video. Assuming the opposite of the conclusion, which is P, so I'm assuming not P. Then I'm writing AP to let you know that I've assumed a premise. You have to do that. Then I see there's another P right above it, so I can bring down not S, and that rule is modus tollens. I hope you know that by now. I see another S, it's in line 1. I can use disjunctive syllogism to bring the T down. I see a number T, it's in line 3. I can use sorry, I cannot do that. I'm using 3 and 2 to get to the not T with disjunctive syllogism, and then conjunction to put everything together. Closing off the box, and then what goes underneath the box goes up above this line is always the contradiction that you put together with a conjunction, or it was already put together for you and it just ended up that then it's the last thing that you do. You put a line under it, and then what goes under it is the opposite of what you assumed. That's the conclusion, so we're done. So there's another way of doing it, assuming the opposite of the conclusion. Then I've got not S from modus tollens on 4 and 5. Now I have T from 1 and 6. That's disjunctive syllogism. Now I have an X from 3 and 7. Also disjunctive syllogism. Then I put the contradiction together from 1 and 8. From 2 and 8 using conjunction, and then I'm stating the opposite of what I assumed it must be true, which is the conclusion, so we're done. And you always have to write from line 5 all the way down to the last, wherever you're starting to the last, and then indirect proof. There's another way of doing it, and in this way we are not assuming a premise. From 2 and 3, I got not T. That's from disjunctive syllogism. If X is true or T is false, X is false, so T must be false. That sounds a little weird, but that's what it is. Then we have an S here. If S or T must be true, T is false, so S must be true. That sounds a little better, but they're both correct. There's another S. If S then P, S therefore P. So that's the most elegant way. We've taken 7 steps. And the other 2 where we're assuming a premise took 10 steps. So on the test, if you're in my class, on the test, you're going to have to assume a premise at the end using conditional proof, but some students get around it. So it's intended that you use conditional proof, so you're automatically going to assume the antecedent of a conditional statement in the conclusion. But on some of the proofs, students get around it with these moves that I've shown you. Okay, that's it.